Hello and welcome back. In this chapter we're going to pull everything together that we've been learning so far, and we're going to do something far more like a realistic Spark programming job. We're going to analyze some subtitle files and see if we can automatically generate keywords for virtual pair programmers training courses. So in the previous chapter we learned how to load in a text file. In practice, be from something like a Hadoop file system or possibly something like Amazon S3. But we've tested it with just a local file. And I introduced to you in that chapter this input.txt file inside the subtitles folder. And what we have in here is a subtitles file. It happens to come from our Docker training courses. It's from both of the courses, and I've combined them all together into a single big file. And the challenge is we would like to be able to take the subtitles file from any of our courses, and we would like to be able to generate automatically a set of 10 keywords for that course. And the keywords, of course, should reflect the major topics in that course. So what we're going to do in this chapter is I'm going to guide you through how you would do that using the tools and techniques that we've already learnt. If you want, you could pause the video now and have a try at implementing this challenge for yourself. However, I don't want you to get stuck and get frustrated and think that you're not doing very well with Spark, because what we've done so far probably isn't quite enough. I've given you all of the fundamental tools such as reduce by key, how to do maps. Certainly the flat maps are going to be very useful for this exercise too. But there will be a few extra tools that you're going to need that we haven't yet covered. If you want to try this for yourself, you can visit the Apache Spark page, spark.apache.org. And on there you'll find a link to the documentation for the latest release. And the documentation's quite good. It gets a little bit mathematical in places and certainly assumes previous knowledge of working in these kinds of environments. But if you go further down, you'll find where to go from here. And I think the most useful page, really, for what we're doing at least, is the RDD Programming Guide. And what they've got in here, let's just scroll down to a random example. So, for example, parallelized collections is what we saw very early in the course, where we can load in an existing collection into the driver program. Very good for testing. And what they give you here is how to do it in Scala, but also, well, Python as well, but here's how to do it in Java. So that's exactly the kind of thing we've been doing earlier on in the course. And you'll find there's a lot of good examples of how to do things in Java. They're covering there pretty much what we've covered so far on this course. If I go back to the top though, I think the important thing I want to point you towards is the section here and here. And this is where they list all of the transformations and all of the actions that are available. Now, just to recall what we covered in a very early chapter, transformations are where we are transforming an RDD from one form to another, or rather we're telling Spark that we want the RDD to be transformed. Spark will lazily evaluate that transformation once we get to an action. So it's worth bearing that in mind. But if I follow the link here, here's a list of all of the transformations that are available. We've covered map, we've covered filter, we've covered flat map. Now we haven't covered everything. For example, if I go a little further down, we haven't covered sorting at all. Now I reckon for processing subtitles and finding out what the most important words are, we're probably going to need a sort of some description. So we will need that. Going a little further down, there are some actions that we haven't used so far, such as take. Now that's going to take an RDD and it will return an array. It will be a regular Java collection, in fact, not an array. It will be a Java list, I think, and it will return the first n elements of the RDD. Now that's going to be very useful because we're going to get very big RDDs now, and we don't really want to be printing everything to the console. So take is a very good way at just having a peek at some of the values in that RDD. Another useful operation is, if I can find it, it's directly underneath. It's take sample. Now, it might not be very interesting to take the first 10 or 20 elements of an RDD because that might be a clump of data in one particular format, but actually there's interesting values scattered all the way through the RDD. So take sample's a useful one. If we call take sample specifying, say, 10 elements, then it will return 10 random elements from that RDD. The point of me showing you this is, of course, you should get used to using the Apache Spark documentation. And if you do want to try this exercise for yourself, then you will need documentation to fill in a few gaps. But whether you do this by yourself or follow my walkthrough, I'll need to give you a bit of advice on what we're actually doing. So you know that we have an input text file, which is a set of subtitles, lots of words basically. Now I suggest that the exercise here really is to do a word count. So somehow split this file up into words and count each unique word that appears in this file. I can see already, for example, that there's the word to here, and it appears at least twice on this screen full of text. So we're going to count that word in the results, and it will have a count of, well, it's going to be a massive number actually, but just looking at this screen full, I've probably missed some, but it's going to be counted as appearing at least 2 times. That will give us a word count, and doing word counts is actually a very common activity in Spark. It's often used as a hello world example actually, but I find that's a bit insulting to word counts because word counts are so important. If you're doing any kind of lexical analysis, then a word count really is one of your most important tools. But I suggest that's not very useful for this, because just counting words in this file, well, we're going to end up with boring words at the top. We're going to end up with words like the and to, and probably words like course as well are not very interesting because that word's going to appear in every single virtual pair programmer's course. So it's not going to be a specific keyword for that course. So for that reason, we have off camera built a file called boringwords.txt. And what's inside here is actually 2 things. First of all, we've included in here just a list of the most common words in the English language. So you'll definitely find words like the and of and to and its and so on. But also what we've done is we've used Spark to run through all of our subtitles for all of our courses all at once. And we've generated a list of words that appear commonly in every single course. So, as an example, I mentioned it before, the word course would appear frequently in our courses, and therefore it's not interesting. And because I always use words like terribly, and I'm always complaining, so I'm sure the word tedious will be appearing in here somewhere. Yeah, there it is. So we've automatically generated this file, and we think these are words that you should be filtering out of your results. Now, rather than you having to load this file into memory, you don't need to do that because I've already done it for you. I've provided a class called util.java. It's just a wrapper around that boring words file so that you don't have to bother loading it into memory. There's just 2 methods in there at the moment, but we could add more. One is called isBoring, and if you specify a word, it will give you a true or false, telling you whether we think that word is boring or not. And I've also provided, just for more readable code, I've provided the inverse operation of that, is not boring. Now you might be wondering, why have I not loaded in this boringwords.txt as a RDD? And I absolutely could have done, but the first reason is I think it would complicate the exercise, and I want to make this exercise achievable. But the real reason is, in real life, if you think about it, this boring words, there aren't that many words in the English language. It's very difficult to know how many words there are in the English language, but it's certainly of the order of no more than 1 million or 2. So I don't think this file is ever going to be that big. If I can just get the properties for the boring words file, at present it's about 89k. And this is actually a genuine, it's not a cut down, it's one that we do use and works well for us at present at Virtual Pair Programmers. So it might get bigger, this file, but it's, it's small. There's really no point in distributing it across an RDD. So, as mentioned in the comments here, this file will be loaded into the driver's JVM, and, unless we feel the need to do otherwise, it's fine just to leave it as a local text file. However, the input file isn't. This is going to be a big, massive file. So I think I've said enough now. Your challenge, if you want to do this yourself, is to have a go at loading this file into an RDD, get rid of all the boring words, count up the words that are remaining, and then find the 10 most frequently used. It's entirely up to you if you have a go at this for yourself. If you do and you get stuck, don't get frustrated. You'll find a full walkthrough after this fade to black.